In this video segment, you learn how to quickly run a Monte Carlo risk simulation. It is as easy as 1, 2, 3. That is, set a profile, set input assumptions and forecasts, and run. To start a new simulation, you must first create a simulation profile, or open an existing profile. Remember that when working on a simulation model, you can continue working on an existing profile if you wish, or change to another profile, or create a new profile. The simulation profile contains a complete set of instructions on how you would like to run a simulation. It contains all the assumptions, forecasts, simulation run preferences, and so forth. Having profiles facilitate creating multiple scenarios of simulations. That is, using the same exact model, several profiles can be created, each with its own specific simulation assumptions, forecasts, properties, and requirements. The same analyst can create different test scenarios using different distributional assumptions and inputs. Or multiple users can test their own assumptions and inputs on the same model. Instead of having to save many versions of the Excel model, the same single model can be used and different simulations can be run through this model profiling process. To create a profile, click on Risk Simulator and select New Profile. If you already have an existing profile, you can click on Risk Simulator, Change Profile, to select the profile you wish. And in this Change Profile menu, you can duplicate, delete, or change to the profile you wish. By the way, you can access all of Risk Simulator's functionalities via the Risk Simulator drop-down list or the 4 sets of icons. When creating a new profile, enter a profile name and be specific and unique so that you can easily identify it later on. The default trials is 1000, and you can change this if required, where the higher the number, the more precise the results. You can see the precision of the results based on the number of trials in the statistics view later on. Pause on simulation error if checked. The simulation stops every time an error is encountered in the Excel model. That is, if your model encounters a computational error, for example, some input values generated in the simulation trial may yield a divide by zero error in the spreadsheet cell, then the simulation stops. This feature is important to help audit your model to make sure that there are no computational errors in your model. However, if you're sure the model works, there is no need for you to check this preference. Turn on correlations. If checked, correlations between paired input assumptions will be computed. Otherwise, correlations will all be set to 0 by default, and a simulation is run assuming no cross correlations. See the videos on correlations for more details. Specifying net random number sequence or seed value is the last option. By definition, a simulation yields slightly different results every time it is run by virtue of the random number generation in Monte Carlo simulation. However, when making presentations, sometimes you may require the same results. For example, during a live presentation, you may like to show the same results that are in some pre-generated printed reports from a previous simulation run. When you're sharing models with others, you may also want the same results to be obtained every time. If that is the case, check this preference and enter in an initial seed number. The seed number can be any positive integer. Using the same initial seed value, the same number of trials, and the same input assumptions always will yield the same sequence of random numbers, guaranteeing the same final set of results. Note that once a new simulation profile has been created, you can come back later and modify your selections by going to Risk Simulator, change Simulation Profile, and selecting the profile, and then Risk Simulator, Edit Profile. Please note that your profiles are stored inside your Excel file, which means when you save the Excel model, the profiles on all the assumptions and forecasts will be saved and available the next time you open this Excel model. There is no need to save any additional files. Next, we'll take a look and see how we set up assumptions and forecasts. The next step is to set input assumptions in your model. Assumptions can be assigned only to cells without any equations or functions. And recall that assumptions and forecasts cannot be set unless a simulation profile already exists. Select the cell you would like to set an assumption on and click Risk Simulator, Set Input Assumption. The assumption name allows you to enter in unique names for the assumptions to help track what each of the assumption represents. Good modeling practice is to use short but precise assumption names. The distribution galleries area to the left shows all of the different distributions available in the software. To change the views, right-click anywhere in the gallery and select large icons, small icons, or list. 25 distributions are available. Depending on the distribution selected, the required relevant input parameters are shown. You may either enter the parameters directly or link them to specific cells in your worksheet. Click on the link icon to link an input parameter to a worksheet cell. Hard coding or typing the parameters is useful when the assumption parameters are assumed not to change. Linking to worksheet cells is useful when the input parameters themselves need to be visible on the worksheets or can be changed as in a dynamic simulation. Please watch the video on multidimensional simulation for more details. Typically, the average analyst does not use the distributional truncation or data boundaries, but they exist for truncating the distributional assumptions. For instance, if a normal distribution is selected, the theoretical boundaries are between negative infinity and positive infinity. However, in practice, the simulated variable exists only within some smaller range. This range can be entered to truncate the distribution appropriately. You can also use the percentile input or alternate inputs to enter data or as a sanity check. For instance, in a normal distribution, instead of entering standard deviation, which many people do not understand what it really means, you can use the percentile input and enter in the 10% or 90% values instead, making setting assumptions much simpler. Or use this alternate percentile input as a sanity check to make sure the 10% and 90 percentile makes sense for your distribution. Pairwise correlations can be assigned to input assumptions here. See the video on correlations for more details about assigning correlations, linear and nonlinear correlations, entering a correlation matrix, and the effects correlations will have on a model. Finally, short descriptions exist for each of the distributions in the gallery. The short descriptions explain when a certain distribution is used as well as the input parameters requirements. You can also right-click on a cell to set an assumption, or you can also use the RS set assumption functions to set assumptions. But for simplicity, we suggest using the set assumptions icons. The next step is to define output forecasts in the model. Forecasts can be defined only on output cells with equations and functions. Select the cell you want to set a forecast on and click Risk Simulator, Set Output Forecast. Specify the name of the forecast cell. This is important because when you have a large model with multiple forecast cells, naming the forecast cells individually allows you to access the right results quickly. Do not underestimate the importance of this simple step. Good modeling practice is to use short but precise forecast names. Also, instead of relying on a guesstimate of how many trials to run in your simulation, you can set up precision and error controls. When an error-precision combination has been achieved in the simulation will pause and inform you of the precision achieved. Thus, the number of simulation trials is an automated process. You do not have to guess the required number of trials to simulate. You can also select Show Forecast Window, which is on by default, allowing you to show a particular forecast window. You can also right-click on a cell to set an output forecast. If everything looks good, click on Risk Simulator and Run Simulation, or click on the Run icon in the Risk Simulator toolbar, and the simulation will proceed. You may also reset a simulation after it has run to rerun it by clicking on Risk Simulator Reset Simulation, or click on the Reset icon in the toolbar. Or click Pause to temporarily stop a simulation run. Also, the step function, that is Risk Simulator Step Simulation, or the step icon on the toolbar, allows you to simulate a single trial, one at a time, which is useful for educating others on simulation. That is, you can show that at each trial, all values in the assumption cells are replaced and the entire model is recalculated each time. Finally, note that in Risk Simulator version 5 and above, we have a super speed simulation, which can run thousands of trials at super speeds. Notice how much faster the simulation runs 1,000 trials. We can also change the number of trials to 10,000 and see how quickly it runs. Watch the video on super speed simulation for more details on how this works. Finally, at the end of each simulation, you can obtain forecast charts. We will see next how to interpret and use these forecast charts. The forecast chart has several tabs, including histograms, statistics, preferences, options, and controls. The probability histogram shows the frequency counts of values occurring and the total number of trials simulated. From here, you can determine the probability of occurrence called confidence intervals. That is, given two values, what are the chances that the outcome will fall between these two values? For example, there is a 90% probability that the final outcome, in this case the level of income, will be between these two values. The two-tailed confidence interval can be obtained by first selecting two-tail, that's the type, entering the desired certainty value, for example 90, and hitting Tab on the keyboard. The two computer values corresponding to the certainty value will then be displayed. You can select the type of tail, enter in a percentage, and hit Tab to get the values, or enter in a value and hit Tab to get the percentage. For example, the two-tailed 90% confidence interval is between 0.8053 and 1.0799, which means that there is a 5% chance income will be less than or equal to $0.8053 and 5% chance of it being greater than or equal to $1.0799. Alternatively, you can select left tail and enter in $1 to determine that you have a 70.43% chance that income will be less than or equal to $1. Experiment with this on your own. Also, notice that the charts are resizable. The Forecast Statistics tab summarizes the forecast in terms of the 4 moments of a distribution. You can rotate between the Histogram and Statistics tab by depressing the spacebar. Please review the user manual for more detailed information on what the 4 moments of a distribution mean, how to interpret these results, how to manually compute them, and most importantly, how to use them. Again, this quick video segment is only meant to show you the functionalities of Risk Simulator and not meant to be a statistics primer. Also, please note that you can use the RS Forecast Statistics function to obtain the simulation statistics of any forecast by clicking on Insert Functions, selecting All Functions, and using the RS function for forecast statistics, just as we're doing here. The Preferences tab allows you to decide if you want to always show the forecast window on top of other software that may be running. Make the forecast chart semi-transparent when inactive in order to compare or overlay multiple forecast charts at once on top of another, or to change the histogram resolution, to change the number of bins of the histogram from 5 bins to 100 bins. And how often to update data in the charts, allowing you to control how fast the simulation runs versus how often the charts are updated. That is, if you wish to see the forecast chart update at almost every trial, this will slow down the simulation as more memory is being allocated to update the chart versus running the simulation. This is merely a user preference and in no way changes the results of the simulation, just the speed of completing the simulation. You can also click on Close All or Minimize All to apply to multiple forecast charts that might be open in one mouse click. Finally, you can click on the Copy Chart button to copy the active forecast chart for pasting into other software applications, for example, PowerPoint, Word, or Excel. In the Options tab, you can decide to show all the forecast data or to filter in or out values that fall within some specified interval or within some standard deviation that you choose. Also, you can set the precision level here for the specific forecast to show the error levels in the statistics view. Remember that if you make a change here, the statistics view will show the truncated distributional statistics. Finally, in the Controls tab, you can change the look and feel of the forecast chart by accessing any of the chart controls such as rotations, 3D effects, colors of the bars, backgrounds, lines, and many other nifty charting capabilities. You can also save all of the chart specifications to apply them in the future on other forecasts. Also, you can change the look and feel of the charts with respect to the number of decimals, chart X and Y axes, titles, and so forth, and perform a distributional fitting on the forecast data. That is, you can take the forecast data points and apply a distributional fitting to determine which theoretical distribution has the closest fit. And you can then show the CDF or PDF of the fitted continuous or discrete distribution. Please view the distributional fitting video for more details on how to perform a distributional fitting to find the best distribution to use. Okay, you're now ready to run your own simulations. We do strongly suggest spending more time on the remaining videos to truly learn how to use Risk Simulator properly, and to review the user manual and Dr. Jonathan Munn's books for more technical details, including his books entitled Modeling Risk, or Real Options Analysis 2nd Edition, or even Advanced Analytical Models. We will see you in the next video segment.